Yeah, welcome to the Higher Mathematics video as part of the straight line topic on equation for a line or equation of a line. What we're going to look at today is to be able to find the equation of a line given the gradient and a point, and to be able to identify the gradient and the y-intercept of a line from this equation. Now, all of this video pretty much is going to be revision from National 5, but there will be bits that will become kind of more complicated and in-depth at higher, and obviously we'll need to use these skills as well. Okay, first part of the revision here is just y equals mx plus c. We know that any straight line can be described with an equation of the form y equals mx plus c, where m is the gradient and c is the y-intercept. And this in higher is predominantly or pretty much exclusively used to identify gradients and y-intercepts to work with parallel lines and perpendicular lines. That's where we're going to use y equals mx plus c. If we need to find a gradient from an equation, we need to make sure it's of this form here. And if we need to find the y-intercept, same goes. Okay, another bit of revision here, parallel, horizontal and vertical lines. We know that parallel lines have the same gradient. Perpendicular lines, remember the gradients, multiply to give -1. We know in a horizontal line that these lines have the equation y equals b. Okay, every single point here is b up. Okay, the y coordinate is b, so that's your equation of line, and that is a gradient of 0. Similarly for vertical lines, every single point here has an x coordinate of a, it has gone a across, so your equation is x equals a, and we know already the gradient is undefined for vertical lines. Okay, this again is another little bit for a revision, y minus b equals mx minus a. We all know this from National 5. The gradient is m, and a and b come from any point at all. Now, this bit here, it is good practice to rearrange this into the general equation, blah, 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 with everything on one side equals to 0. That's not necessarily needed to get any marks. It's just to let you to know that's kind of good practice. Most of the time, what we'll do is rearrange it into y equals instead, because that's useful to find points of intersection. Okay, so what we're going to do, you know all this already. I'm just going to look at a couple of examples, okay, and you can kind of see how maybe it's going to become a little bit harder, higher. Okay, so we need to write down the gradient and the y-intercept of the line with that equation. Now we know to do this, we need it to be y equals. Okay, y equals everything. So what we're going to do is we're going to change the subject of this so that it's y equals. First thing we can do is subtract 2x from both sides and add 6 to both sides. We're going to get 5, y is equal to -2x plus 6. Then divide everything by 5. You could do all of the right side in one, but I'm going to do it in two different bits because we know it needs to compare to y equals mx plus c. Okay, so y equals mx plus c. We can compare that. We can see the gradient is -2 over 5, and the y-intercept is 6 over 5. So the gradient is -2/5. The y-intercept is 6 over 5. Job done. Okay, anytime you need to lift it out, it needs to be as y equals. Okay, that's a big, big thing there. Find the equation of the line passing through the point A, and that should say B there. Let's stick that in, sorry. Okay, we're looking for the equation of a line. We know we're going to be using y minus b is equal to m bracket x minus a. Okay, we know we're going to be using that, and to use that, we need the gradient, and we need any point. We already have a point here. Let's use 5, 2 to avoid negatives. We need to find the gradient. We can do that, that's not a bother. y2 minus y1 over x2 minus x1. Okay, so -3 subtract 2, -2 subtract 5. It's -5 over -7, so just 5 over 7. Okay, so that's 5/7. So that's going to be y minus 2 is equal to 5/7 of x minus 5. We need to be able to rearrange this into its simplest form. What I would do here to do that, because I'm dealing with sevenths, I don't really want to deal with fractions if I can help it. I'm going to multiply both sides by 7. So that's going to be 7y minus 14 is equal to 5 times x minus 5. So 7y minus 14 is equal to 5x minus 25. So 7y is equal to 5x minus 11. Okay, and that'll do that. You're in the simplest form. You've got all the y's, all the x's, and all the numbers together. Okay, so we've done that before. We've dealt with that. Just using y minus b equals mx minus a. We'll have a lot more of these fractions involved at higher, but we can deal with them. Okay, and example 3, find the equation of a line perpendicular. Okay, so perpendicular, that's important, to 3y plus 2x equals 5 that passes through that point. Okay, so again, I'm finding the equation of a line, so I'm going to be using this. So I'm going to write that down. I need the gradient. Do I know that yet? Nope. Do I know a point? Yeah, I do. I've got minus 5 too. Okay, so here's the trick. I need to figure out the gradient. Okay, well, if I've got the line 3y plus 2x is equal to 5, I can rearrange that so that it's y equals. So I know the gradient of that line. So 3y, subtract 2x from both sides, is going to be minus 2x plus 5. Divide everything by 3. There's the equation of that line there. So the gradient of that equation is negative 2/3. Okay, and we know that if we're looking for the perpendicular gradient, we just have to flip it and change the sign. So 3 over 2, make the negative a positive. Okay, and again, we want a little bit of explanation in there to make sure we're getting all marks, since negative 2/3 times 3/2 is equal to negative 1. Okay, and then that's how we've got everything we need. Gradient is 3/2. That's your point. So y minus 2 is equal to 3 over 2 x. Well, you're subtracting negative 5, so let's make that a positive 5. Multiply by 2 to get rid of the fraction. So 2y minus 4 is equal to 3x plus 15. I'm just going to scroll down a bit here just to get a bit more space. So 2y is equal to 3x plus 19. Okay, and there is your equation of your perpendicular line that passes through that point. Okay, as I say, everything here is revision. Okay, you may have a little bit of perpendicular work, but you know that now. Okay, so it's just putting that together with the equation of a straight line stuff that you know. Any issues, need any more practice, talk to your teacher. Thank you.